Jocelyn's riding a unicycle back and forth along a straight east-west track. Jocelyn's velocity, v of t, is given by the function below, and it's measured in meters per second. The table below gives values for v of t at selected times t. So at 0 seconds, we see she's going 2 meters per second. At 40, she's going 2.5 meters per second, etc., etc. The first question asks us to estimate by using a left Riemann sum with 3 subintervals indicated to estimate the total distance Jocelyn travels over 60 seconds. And we have to use proper units. Now at first you might be like, what do I do? Well, the first thing to keep in mind is that it's a Riemann sum, right? And so we're going to be finding the area of rectangles. Riemann R, rectangles R. And now, remember, we're finding the area of 3 different rectangles, 3 subintervals. And when they say the subintervals indicated, they're talking about this. From 0 to 10, from 10 to 40, and then from 40 to 60. Now, why is that useful? I'm going to remind us that rectangles, whenever we're finding their area, we need the length and the width. And the width is given by those intervals. I call these our delta x, or in this case, we can call them our delta t, how those x's and t's are changing. In the first case, our width is 10 from 0 to 10. From 10 to 40, that width will be 30. And then from 40 to 60, that width is 20. Now the next thing we need to find, if we're trying to find the area of a rectangle, is the height. Or the length. I'm going to call it the length because we know that the area of a rectangle is given by length times width. Length times width. And so now we can see that the lengths are given to us because those are going to be how far up the function we go. But which values do we use? The question tells us a hint by telling us that this is a left Riemann sum. Since this is a left Riemann sum, we always want to use the values on the left. So our heights, for the rectangle that is 10 wide, we're going to have a height of 2. I'll draw a little arrow connecting them. For 2.3, that one's going to go to the one that's 30. And 2.5 is going to go to the one that's 20. And so we're going to use those to make our estimate. I'll draw those out. Our total area, or total distance in this case, total distance is going to be equal to the sum of those areas. We're going to get 10 times 2.0. Oop, maybe I'll put the 2.0 in blue so we can see where it's coming from. 2.0. That's the first area. Plus the next area, which is going to be given by 30 times 2.3 plus that final area, which will be given by 20 times 2.5. Again, because we're using a left Riemann sum. Alright. I have my handy dandy calculator that I'm going to use to calculate these values. So 10 times 2.0, well, I know that one's going to be 2. 2 plus 30 times 2.3. Oh, sorry. 10 times 2.0 is not 2, it's 20. Foolish shit. There we go. 20 plus 69 plus 20 times 2.5 would give me 50. And so we'll add these together. 50 plus 20 is 70, plus 69 will give us 139. Now we're not done there. We have to also include our units since we're finding the area under the meters per second curve. Area under this, that tells us our final unit will be in meters. So we're going to say 139 meters. Now, is this an overestimate or an underestimate? That's what the second part of the question is asking. And I'll write in a different color. Maybe I'll write in green here. Is this an overestimate or an underestimate? Well, we can think about this by figuring out, well, what's happening to our function? Is it increasing or decreasing? And we can just draw a fake version of this function. I can see that our function is increasing. It goes from 2.0, so let's say here's 2.0, to 2.3, to 2.5, to 4.6. We'll draw it there. It's increasing. Again, these are just random. I'm just trying to draw a general idea. And let's figure out, well, what's happening to those areas. Would it be an overestimate or an underestimate? If we're doing a left Riemann sum, it would look something like this. And now what do you notice? You might notice that there are some empty spaces, and I'll highlight that in red. We can see that there's this part here, and this part here that are not covered by our estimate in these yellow rectangles down here. Since we have an increasing function, with the left Riemann sum, there is going to be an underestimate, and that's what we would write. Underestimate, because this is a left Riemann sum on an increasing function. So, Jocelyn probably rode a little bit more than 139 meters, but we don't know exactly how much. We're just going based off our estimate on the table.